Hello. What you see in front of you is my Rover. It's a RC controlled car which has a relay module, a battery bank attached to it, an IR receiver, and an Arduino Uno right here. And obviously 4 motors for each of the wheels. And you have one part of a breadboard, which is the positive and negative rail, just so it can power all the motors and the relay module. So why did I do this project? We've all played with RC toys, RC cars, RC boats, RC trains in our childhood. But what about the idea of making one yourself? That's what really inspired me. So here it is in all its glory. Mostly everything is attached to this cardboard chassis with blue tack, but these motors are attached with super glue to the cardboard chassis. Now, how do I control this? Well, with this Sony remote. This is my TV remote, and I had to go to the manufacturer's manual to decode the IR codes for the up arrow, left arrow, right arrow, and backwards arrow, so that I can control this Arduino project. So you've got the code over here for the Rover. You can see that there are the motors which are set as outputs, and then you can see for each kind of code whether each of the motors will be on or off. Remember, with the relay module, the low signal means that the relay module will be on or allowing current to flow, and high means that the relay module will be off, so not allowing current to flow. Now, relay modules are a little bit more complicated than that because they have 3 pins per relay module, as you can see here. You've got the common, and then you've got the normally open and the normally closed pin. What this means is, if this relay module is on, so it is allowing current to flow, then this normally open pin will have current flowing through it. But because this is a normally closed pin, there will not be current flowing through it if this relay module is on. But if it is off, then there will be current flowing through this pin, but not through this. So the main idea is, with a relay module, you pass a current through it, through the middle pin, and you take another wire and take it out from either the normally open or normally closed side of the relay, and then you take it to whatever motor or LED or any other thing that you want to control with it. So the idea is that the relay module controls when the current flows and when it doesn't flow with the digital signals from the Arduino. Now I will show you how this works in a second with the remote and all the functions that I've coded onto it. Now obviously I won't be able to show you the car moving on the ground just yet, but I just wanted to show you the relay module at work. So if I was to press the forward button, you can see that all 4 LEDs are on, which means that all 4 relay modules are allowing current to flow, and you can see that all the 4 wheels are currently moving. If I was to click the left button, so the car was to go left, you can see that the 2 wheels on the right hand side are on, so this will obviously move the car to the left, and these wheels are off. If I was to press the right button, you can see that these 2 wheels are now moving. What about if I press the backwards button? You might ask, well, why did they stop? Why isn't the car wheels moving backwards? Well, it's because I don't have the module to reverse the current. So all I can do currently is stop the car when I press the backwards button. I don't have the module to reverse the direction of current, because obviously, as you know, motors, you can change the direction a motor spins by just changing the direction of current. But with a relay, all you can do is change whether it's on or off. And even in this case, I cannot control the speed of the RC motors because I don't have a variable resistor. But this is the best I can do with their Rover, and it also looks much like a moon buggy. So let's take this outside for a spin. Those of you that have worked with Arduinos before and or with Raspberry Pis Well, might be wondering why I've used a relay module. Like, why couldn't I have just connected the motors directly to the digital pins on the Arduino Uno? Well, it's because the Arduino Uno doesn't supply that much of a current through the digital pins. I think it's around 20 milliamps. And 20 milliamps is nowhere enough to drive 4 big motors like this. That's why when I connected these pins initially to the digital pins on the Arduino, they weren't spinning at all. So after doing a little research, I found that these motors need actually a direct current of 5 volts. So that's where you can see what I've done here. I've got a positive rail and a negative rail, and I've taken the 5 volts from the Arduino, plugged it into the positive rail, and taken a positive wire and plugged it into each relay module, and then taken another wire and taken it to each of the 4 motors. So this way every motor has access to 5 volts in parallel, and they can all move at a great speed like you saw previously. So that's why I've had to use a relay module. It's because there's only one 5 volt pin, and I obviously cannot control whether the 5 volt pin is on or off. It's just a constant 5 volt pin. So that's why the need for a relay module instead of plugging the motors directly in. Also, it helps with the aesthetics, because it kind of looks like the gas cylinders of an engine. So it works aesthetically too. And over here I've got my battery bank. Well, really it's headphones, but they double as a battery bank. So that's also blue tacked on there, on top of the Arduino. So it makes for a fully compact kind of Rover situation. I can charge the battery without ever having to take it off because I have the USB-C here. So it's kind of an all-in-one really. And the fact that I'm using my Sony TV remote just makes it all the more better. The reason I had to choose this remote is because the range is good on this. There was a smaller remote that came with the Arduino, but the range on that was not too good. Like, for example, if the Rover was literally like half a meter away, the signals wouldn't be decoded properly with the IR receiver, which is here. So that's why I chose the Sony remote, because its range is much better and it's a stronger signal. Also, you can see that if I click a button, the IR receiver is beeping. Now obviously I'm pressing the backwards button, so nothing is happening, but I just wanted to show you that the IR receiver is active. Now let's take it outside. I've brought the car outside now, but it's pretty dark, so I decided to make a new addition to the Rover. The 2 headlamps on the front of the Rover to light the path the Rover takes. Those who have an inner detector in them may have noticed that the brightness of the headlamps dims when all 4 motors are on, but gets slightly brighter when the Rover is turning. This is because the same 5 volts potential difference is being shared among all the components on the Arduino board. So, naturally, when there are more motors turning, there is less current to go around, and more resistance due to the extra components taking current. When the Rover is going straight, there are 4 motors on, so the LEDs get a less share of the current. But when the Rover is turning, only 2 wheels on the outer side of the Rover are turning, so there is more current for the LEDs to go brighter. But thank you for watching my video, and I hope to upgrade this Rover in the next video by adding internet controlling capabilities to finish off the project. Thank you.